In this video, we'll be looking at redox problems. We've got a few simple steps, 1 through 8, listed over here on the right side so that we can follow along. Now, I've already got my problem laid out here, and it says balance this reaction. Before I balance anything, I want to figure out what the oxidation numbers of each of these atoms are. And so I'm just going to go ahead and do that. The first thing I see is my sulfate here, my sulfite, SO3 2-. So I need to figure out what the oxidation number for the sulfur and the oxygen are. I know the entire ion is going to have a total charge of -2. And so I want most of my negatives to cancel out that I'm going to get from those oxygens, because each of those oxygens is going to have a -2 for the oxidation state. And there are 3 of those. So if I look here, I'm going to have 3 oxygens that I'm going to have to cancel out with whatever my charge of my sulfur is. So sulfur is going to be equal to -2 plus 6, because whenever I take this is actually going to be -6, and so I would need to add 6 to both sides to be able to cancel that out. And if I take -2 plus 6, that means the charge on my sulfur actually needs to be +4. And so I've got my oxidation state on this oxygen and sulfur. Next thing I need to do is look at my manganese and my oxygen, this next ion. So manganese and oxygen. Once again, oxygen is going to be -2, and I just need to figure out what the manganese that's paired with it is going to be. So my manganese plus 4 times my charge of oxygen is going to be equal to -1, because that's the total charge on this ion. So manganese is equal to -1. This entire thing right here is going to end up being -8. So if I add 8 to both sides, that'll give me my charge of my manganese, which according to this should be +7. So that's a pretty big positive charge there on that manganese. Then I'm going to move on over to my SO4 2-. Sulfur, I'm going to have to figure out. Oxygen also is going to have to be figured out. I know that those are going to be -2 though, because once again, oxygen is always -2 whenever it's not in peroxide. I'm going to have to figure out what that sulfur is though. I know the charge of sulfur is going to be equal to whatever it needs to be to cancel out those 4 oxygens. And we know each of those oxygens is -2. And our total charge on the ion is also -2. Whenever I go ahead and simplify this, this will give me -8. And so I'm going to have to take sulfur is equal to -2 plus 8, because I'd have to add 8 to both sides. And so sulfur is going to be equal to +6. And then the last thing is this manganese right here. This says it's Mn2+, so this manganese has just got an oxidation state of +2. Now, looking at this, I see some elements that are changing. First off, I see my manganese. Right here it's +7, over here it's +2. And so that's going to be in one of my half reactions, because that one's definitely got some changing oxidation states. The other thing I see that's changing is my sulfur, because my sulfur is going from +4 to +6. The only other element I have here is oxygen, and oxygen is always -2 in each of these cases. And so that's just going to be something I'm going to have in my problems, but it's not going to be something that's going to determine what's a half reaction and what's not. So right below that, I'm going to write my half reactions, one for sulfur and one for manganese. My first half reaction for sulfur is going to have my SO3 2-, and then it's going to skip the manganese, that manganese ion, because that's going to go in our second half reaction. And the only thing on our product with sulfur is going to be this SO4 2-. Our other half reaction is going to have the stuff with the manganese, because that's the other thing that's got an oxidation number that's changing. So I've got my 2 half reactions going here. That's our first step, is write 2 half reactions. After that, we're going to balance everything that's not hydrogen or oxygen. Sometimes this is already balanced, sometimes it's not. If it's not, you need to go ahead and balance it. This is not the time to worry about hydrogens and oxygens, so if you've got anything else that needs balancing, you're going to go ahead and do that now. Looking at our half reactions, we've got sulfur, that's balanced. We're not worrying about the oxygens. In the second problem, we have some manganese. That's already balanced. Once again, don't need to worry about it. If we needed to add some coefficients, we could, but in this case, we don't need to. After we do that, we're going to head on over to step 3. Step 3 means that we're going to balance the oxygens by adding water. In our first reaction, we have 3 oxygens in the reactants, 4 in the products. What this is going to tell us is we need 1 more oxygen in the reactants, and the way we're going to do that is by adding on 1 water molecule to get 1 extra oxygen. And then for the second reaction, we have 4 oxygens on one side and none on the other side, so we're actually going to have to add on 4 waters here to be able to get the right number of oxygens. After we figure out the right number of oxygens to add by adding water, we're going to have to balance the hydrogens. This is where we're going to get some bigger numbers. In this first reaction, we have 2 hydrogens in the reactants, but none in the products. So we're going to add 2 H pluses here to get enough hydrogens. In the second one, we have none in the reactants, but we have 8 in the products. So we're going to add 8 H pluses to be able to get the right number of hydrogens on each side. So we've got everything balanced now except for the electrons. We're going to have to do those still. Whenever we go to balance the electrons, what we're going to have to do is figure out the entire charge on each side of the reaction. For our first problem, or for our first half reaction, we see water and we see SO3 2-. Only one of those has a charge, and so that's the only one we're going to really care about. So this entire side right here has a 2- charge just from that one that has the charge on it. On the other side, we actually see 2 things that have a charge. We see a -2 from our SO4, and we also see the hydrogen ion over here that has a +1 charge, except there are 2 of them, so that's actually +2. And if we have -2 and +2, that gives us a total charge on that side of the reaction of 0. Now, one side is more negative than the other. Whichever side is going to be more positive, which in this case is the side that's 0, is going to have to get extra electrons. In this case, we're going to have to add 2 electrons to subtract 2 from this and make both sides -2. We can't add protons to make one side more negative or more positive. We can add electrons to make one side more negative, so that's what we're going to do. And so that balances out our electrons in the first half reaction. Now we need to do this for the second half reaction. In our second half reaction, we have 8 hydrogens on one side, so that would be +8, and we have 1 negative charge on the other one, and so that gives us a total charge on that side of +7. On the other side, we have Mn2+ and some H2Os, and some water. The water, once again, has no charge. It's neutral, it's fine, but we have some charge on that manganese, so that's what we're going to need to worry about. That manganese has a 2+ charge, so we're going to put +2. Neither of these are 0, and that's okay, because we just want to make them match. If one side has a 7+ charge and the other side has a 2+ charge, the 7+ is more positive, and so that's the side we're going to have to add the electrons on to make it more negative and make them be able to balance out. The difference between those two is 5, because if we take 7 minus 2, it gives us 5. So that means I'm going to have to add 5 electrons onto the reactant side of that second half reaction. Looking at this, I can see that I have different amounts of electrons in each of those reactions, which is where step 6 comes in. I'm going to multiply each of the half reactions by some number to make them equal the same number of electrons. The first reaction, I have 2 electrons. The second one is 5. The smallest number I can multiply them both into and evenly is going to be 10. So that means I need to multiply the first reaction by some number to get 10. Same thing with the second one. The easiest thing to multiply 2 by to get 10 is going to be 5. And the easiest thing to multiply 5 by to get 10 is going to be 2. And I'm going to do that to the entire reaction. So I'm just going to rewrite these down here with the new coefficients. Distributing this 5, I should get 5 H2O plus 5 SO4 2- gives us 5 SO4 SO3, this is a 3, SO4 2- as a product, plus 10 H plus 10 E negative. And then in the second reaction, I'm going to distribute that 2, so I'm going to get 10 E negative plus 16 H plus 2 MnO4 minus, and then that's going to give us 2 Mn2 plus, and 8 H2O is our other product. And then from here, I needed to go ahead and follow my last step, or my second to last step, which is add them together and cancel out things that are going to be the same on both sides of the reaction. I do see some things in my two reactions that are going to be identical to each other, or at least identical enough so that we can cancel some of them out. The first thing I see is, of course, my electrons right here. There are 10 of them in each of the half reaction. Those can go away because those are going to cancel out exactly, because I have 10 in one reactants and 10 in the products, and that means I can just go ahead and get rid of both of those. So those can go away. Another thing that I see that's going to be in both of the reactions are water. In the first one I have 5 waters, in the second one I have 8. That means I can't cancel out all of the waters, but I can cancel out all of them from the first reaction and 3 of them from the second reaction by canceling out 5 of those 8 waters, so we're in the second reaction. So now I have 3 H2Os in that second reaction. The other thing, the very last thing I see that's going to be able to cancel are my H pluses. There's 10 in one reaction, 16 in the other. So that means I can cancel out 10 of them from both reactions. These are going to go completely away, and then 10 of these are going to go away, leaving us 6 H pluses in that second reaction. Now that I've canceled everything that's identical, I can just go ahead and copy that down and add those two equations together to get my final answer. So what I'm going to do is I'm going to take my 5SO3 2 minus plus 6H plus 2 MnO4 minus. That's everything from my reactants from both half reaction. And then I'm going to have 5SO4 2 minus plus 2 Mn2 plus those 3 waters that I had left over. And that's going to be my final problem.